Hi, and welcome to this quick video demo of an integration between Cisco Spark and Splunk utilizing Spark's built-in APIs and Splunk's alerting capabilities. For those who might not be familiar with Cisco Spark, it's a business messaging application that combines room-based persistent collaboration with multi-party video, screen sharing, document sharing, and other powerful business features. Spark also supports endpoint registration and PSTN access in a UCaaS mode through Spark Call, and it can even integrate with an on-prem Cisco UCM cluster in hybrid mode. Splunk, of course, is the preeminent machine data analytics platform. Its real-time architecture and schema-on-the-fly design allow it to scale easily from the desktop to the data center, and its agile reporting and analytics capabilities allow for fast time to value. To get started with the integration, we have to create a script for Splunk to utilize. In this case, I decided to use Python. Because Splunk normally calls scripts using the shell, we have to include the shebang directive for the Python interpreter. Not abnormal to have to do that anyway, but just know it is critical here. Next step is we import our modules, and so we're using a couple built-in modules like CSV, gzip. Notably, I'm using PyCurl and tinyurl, which are third-party modules. They're easily installable by easy install, or you can download and install whatever method you prefer. I'll include links in the video description below. I define a couple of variables here as constants. So this is the URL for the messages API. And then string OAuth and string room ID would actually contain the OAuth token for the user that you want to post the messages and the room ID for the room that you want the messages posted to. These are easily obtainable through the developer website, Spark developer website at developer.ciscospark.com. And I'll leave a link down in the description as well. When Splunk calls a script, it actually includes several command line arguments, and so those contain a couple pieces of data that we're actually very interested in using. One is arg8, which is a URL, actually I guess a file pointer to the location of a gzip CSV file on the Splunk file system that contains the raw values for the alert. So Splunk does not pass that data to the raw data to the script natively. It requires you to actually call it and retrieve it if you need it, so that it's not wasting data space when it's passing the script back and forth. So we use the gzip module to open that, and then we use the CSV module to actually read the raw alert text out of it into the string event variable here. Next, we create the message that we're going to post into the Spark room. And so it's a combination of text. I've included here a time module to generate a date time value for a timestamp, the raw alert text here, and then I used a tinyurl module against one of the other command line arguments that's passed. So this is actually a URL to the alert within Splunk, and it's a very long URL, cumbersome to deal with and too much to display. So tinyurl shortens that up for us perfectly. We use the JSON module to JSONify our fields before we post them, and then we use PyCurl to actually post the data to the Spark API. 26 lines of code, pretty simple, easily extensible, great start for the basics. So this has to be uploaded to the Splunk server, and so to do that, we'll actually go into the scripts directory, which is located at the Splunk home/bin/scripts path. The file would be uploaded here, and I've already got it in this case. So, oops. Sorry about that. So I've actually already got it uploaded here. I did a change mod on it just to change the owner and group to the same as all the other files in the directory. I don't know if that's actually required or not. But didn't have to make it an executable or anything like that to get it to work. So basically upload the file, again, to the Splunk home/bin/scripts directory. Once you've done that, you've got to actually create the alert. So we'll go into Splunk for that. To create an alert, you start off with a search. In this case, I want to look at invalid logons through SSH for this AW host that all this stuff is located on. So I created an index just for my Linux_secure logs. And named it Linux_secure. So I've actually got a previous search here that will pull up the records we're interested in. So index equals Linux secure, again, just looking at those SSH records, looking for the string invalid space user. with the and Boolean and the word from. So both of these have to match in order for us to match on a search. I'm going to set us for a 4-hour search period, and it does actually return records, and all the records appear to be correct formats. So that's good. This is what we want to see. This is the data that I want to alert on now. In order to do that, I take the search and I save it as a alert. We're going to give it a descriptive title. So invalid SSH logins real time. Description, I'm not going to bother with. Permissions, I'm not going to touch. Alert type, I am going to set to real time. You can set it as scheduled and run it on a scheduled basis. I want to look at real time alerts every time they come in, every alert. Trigger conditions, I'm going to leave on per result. It's not a ton of data, so we had 12 events in the past 4 hours. I'm not going to worry about throttling it. If it was thousands of events per an hour, maybe. One other thing too, if we throttle, we're actually going to lose granularity around the IP addresses that are sending the attacks because we're throttling on the search, not on the data within the search. So something to bear in mind. Trigger actions, I'm going to add a run a script action here. And so for this, all we need is the file name for the script that we want to execute. And you'll notice over here it is located in Splunk home /bin/scripts. We'll click save and view alert, and that's it. So the alert's set up, the script's set up. We could edit the script here if we wanted to. We don't need to. It is enabled. App search, permissions, private, everything that we set up is set here. At this point, we can pull our Spark room up. So I've created a Splunk Alerts, Spark room, and this is where my messages are posted to. So what we do here is if I pull up a SSH window and attempt an invalid login, we should see in just a minute the alert come up here in Spark, and it has been taking a few minutes for messages to post today, so I do apologize. There it goes. So we have the actual alert that just came up here. This is the host. This is that text part of the message, the date timestamp that I included. This is the raw text from that alert and the URL. If I click on the URL, it will actually open up within Splunk, and I can see the full detail of the alert here. Pretty simple. Again, easily extendable. You could do a lot with this beyond this part. For example, if you wanted to extend the capabilities for a knock 1 to be able to block this host, you could actually use the Spark webhook API to be able to send commands back to a bot that could then take and execute those commands in a templated fashion, so that they wouldn't have to actually have access to, for example, an edge firewall or a edge router or anything like that. They could just rely on the bot to actually execute them commands for them. So I'll put some details in the description for the video. If you have any questions, please post a comment. Thanks, and have a great day.